our commands that we talked about in class today. So right here in the diagram, I'm going to show you what our tasks will start out. I show a diagram. Here's a normal distribution, actually standard normal. And I want to find the area, the cutoff that has 5% above. That's a critical value. That's my first task. And I'll show you how to do that. So I have a standard normal. So I go to the R console, and for a standard, to get a critical value, I do qnorm. Now the area less than 5% is here, so 95% is here. And then I should put the mean and the standard deviation, but I'll show you a trick in a second. And I hit that, and it says the cutoff should be 1.644. So right here is 1.644, has 5% above it. By the way, when it's standard normal, you can actually leave off the 0 and 1 and just do that. If I had a normal that didn't, like I wanted to say, oh, what's the cutoff for a normal with mean 10 and standard deviation 2, then I could do that too. For that particular normal, the value 13.28 would have 5% above it and 95% below it. Okay, let's do the same thing here, but kind of reverse. Here's the same standard normal. Notice it's centered at 0, has a standard deviation of about plus or minus 1. But I want to find out for the cutoff what's the area less than 1.5. That's different from here. Here I start with a probability, 0.05, and I find the cutoff. Here I'm given the cutoff, and I want to find the probability of being less than that. So that's easy too. Instead of Q, we will use P. Oops, we put in the cutoff we want. Mean 0, standard deviation 1. And it said the value, that the probability is 0.93, so there's a 93% chance. The area down here is not 0.93 below 1.5. By the way, if I want to simulate it, rnorm, I could simulate 10 random normals with mean 2 and standard deviation 3. There they are right there. Okay. Same thing I can do with a t-distribution. Let's say we want to find the cutoff that has 5% above it for a t-distribution with 10 degrees of freedom. I would just do Q, because I'm getting a critical value, T, that's my distribution. If I want 5% above, I want 95% below. And here I just have to say the degrees of freedom. So for a t-distribution with 10 degrees of freedom, the chance of being 1.81 or lower is 95%, so the chance of being 1.81 or higher is 5%. Same thing, what if I had the value 1.5 and wanted to know the chance of being less than 1.5 for a t-distribution, 10 degrees of freedom? I would do PT. So there's a 91% chance, and I can simulate it, RT. If I want 10 t-distributions, things similar from t-distribution. By the way, let's look at one that has a very low. I'll make a histogram of first 100 from degree of freedom 10. See, that's not too abnormal looking, is it? But what happens when I drop my degrees of freedom of a t-distribution? Gets a lot more outliers. So let's look at 1. Oof, look at that distribution. There's most of the data, but then there's all these outliers. How about degrees of freedom 0.5? Ooh, here's most of the data. Here's one gigantic outlier at about minus 400,000. Oof. Okay. All right. Let's do the same thing with F. Let's look at an F distribution. I'm going to plot one really fast. So I'm going to make a sequence of numbers from 0 to 20 and make them length 1,000. That's so I can plot it. Then I'll do the plot. Plot x value. You don't have to do this, but I just want to show you what a distribution with degrees of freedom 2 and 3 looks like. So x val, the y val is going to be df. Wow, that's density of an F distribution. at the x values with first degree of freedom is 2 and the second degree of freedom is 3. Okay, let's see what this looks like. Wow, so that's I want one that goes up and drops down. Let's try degree of freedom 4 and 5. How's that? Better? Aha, that's a cool looking one. Look at that. It goes up, drops down. That's a typical F distribution. So let's say I want to find the cutoff that has 5% above it. Guess what I do? Q, F. I want 5% above, so I want 95% below. By the way, you've got to be careful with that because this is not a symmetric distribution. And then I'll put degree of freedom. You have to put in degrees of freedom. 2 and no, 4 and 5. So it says the value 5.19 has 5% above it. So right around there. There's 5% out here. What if we want to switch that around and get the probability of being less than 10 for a that F distribution? So here 10, the probability of being less than 10 is 0.98673. And if I want to simulate some F distributions, I can do 10 of those, for instance, easily. There we go. All right, that's it. And by the way, when you're done with R, you can just hit Q, and then you decide whether you're going to save or not. Save your workspace. If you save, you get to start up with all the stuff you can use the up key to get earlier stuff. If you don't save, it starts over. So I won't save, and that's it.